Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore China's powerful new artificial sun magnet, a colossal engineering achievement designed to withstand extreme heat and bring scientists closer to producing clean fusion energy. This extraordinary machine reveals just how far scientists are pushing the boundaries of modern engineering. China may soon be able to launch its own private sun. It's 21 meters long. It weighs as much as nearly 100 African elephants. It must survive temperatures colder than outer space while holding plasma that's 10 times hotter than the sun's core. And it has to keep doing that for 6 decades. Beijing, as per reports, has achieved a fusion breakthrough. The nation completed and tested the world's largest superconducting fusion magnet, a critical component designed to create an invisible magnetic cage capable of containing matter at 150 million degrees Celsius. The breakthrough moves Beijing another step closer to its long-term goal of generating commercial fusion power. Here's all you need to know about what may be one of the most extreme engineering projects humanity has ever attempted. At first glance, it looks like a giant steel ring. In reality, it's a 21-meter-long, 12-meter-wide, D-shaped superconducting magnet weighing 582 tons. That's heavier than a fully loaded Boeing 747. Its job isn't to produce electricity. Its job is to do something arguably even harder: stop the hottest material ever created on Earth from touching anything. Inside a fusion reactor, hydrogen is heated until it becomes plasma, a superheated soup of charged particles. If that plasma touches the reactor walls for even an instant, it cools rapidly, damages the reactor, and the fusion reaction ends. The only way to prevent that is to suspend the plasma in mid-air using immensely powerful magnetic fields, creating what scientists often call an invisible magnetic cage. Here's the number that may surprise most people. The sun's core reaches roughly 15 million degrees Celsius. China's fusion reactor aims to operate at around 150 million degrees Celsius. That isn't because scientists are trying to outdo the sun. The sun's enormous gravity naturally squeezes hydrogen atoms together, allowing fusion to happen at relatively lower temperatures. On Earth, there's no such crushing pressure. Scientists have compensated by making the plasma dramatically hotter, so hydrogen nuclei collide and fuse often enough to release energy. The engineering challenge becomes even more astonishing. While the plasma burns at 150 million degrees Celsius, the magnet surrounding it must remain at around -269 degrees Celsius, just 4 degrees above absolute zero. Only at those ultra-low temperatures can superconductors carry enormous electrical currents without resistance. So, inside a single machine, temperatures differ by nearly 150 million degrees over a relatively short distance. Very few technologies in the world operate across such an extreme thermal range. 100,000 amps, enough electricity to power a city. The magnet doesn't just need to be cold. It also needs to carry more than 100,000 amperes of current while wasting virtually no energy. To achieve that, engineers reduced the electrical resistance at critical joints to nearly zero, allowing electricity to flow continuously through superconducting coils. Without that, sustaining fusion for long periods would be impossible. Most cutting-edge scientific instruments need to be upgraded every few years. However, China claims this magnet has been engineered to operate reliably for around 60 years. During that time, it must repeatedly withstand intense radiation, powerful magnetic forces, and enormous mechanical stresses without losing performance. Designing a machine to survive 6 decades under those conditions may prove just as difficult as achieving fusion itself. Nuclear fusion has long been regarded as the ultimate energy prize because it promises electricity without burning fossil fuels. Unlike today's nuclear reactors, which split heavy atoms, fusion combines light hydrogen atoms to release enormous amounts of energy. The potential rewards are enormous, including fuel derived largely from hydrogen found in seawater electricity generation without carbon dioxide emissions, no risk of a runaway nuclear meltdown, and far less long-lived radioactive waste than conventional nuclear fission. That promise has sparked a global race involving China, the United States, Europe, Japan, and several private companies investing billions of dollars in fusion research. While China hopes to begin fusion power generation around 2030, many experts believe commercial deployment could still take decades. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.